All right, folks, it's 10 o'clock, so let's get this party started. Welcome to the August 3rd, 2023 installment of the Long Coffee Break. I'm Matt Bilsma, sales engineer at Long, and today with me is Sam Clemens with Johnson Marcraft. As a way of introduction, Sam is being beamed in today from the great city of St. Louis, where he makes his home and where Johnson Marcraft is located. He is a fellow champion of sarcasm, and he is the namesake of a treasured American author and humorist, Samuel Langhorne Clemens, most commonly known by his pen name, Mark Twain. Speaking of Mark Twain, one of Sam's favorite Twain quotes is, "It is better to keep your mouth closed and let people think you are a fool than to open it and remove all doubt." So with that, Sam, drop some knowledge on us and prove that Johnson air rotation isn't some sort of foolish technology.
Man, what an introduction. I'm gonna have to go back and rewatch that, Matt. Thank you.
No problem.
Pleasure to be with you all this morning. Again, Sam Clemens, and I'm a self-proclaimed mediocre engineer from Horizon Companies in the great state of Missouri. So greetings from Cardinal Nation to you all. Today, we're going to be running through the quick and the exciting topic of air rotation. And so what we're talking about here is an HVAC solution for big open spaces. And the first question is, why is this topical, right? I know many of you are from diverse backgrounds. And just to share a little bit what we're seeing in the national landscape in terms of the economy and market as a whole across the industrial and many different market sectors, is that what we're historically allowed to be rather unconditioned spaces or kind of heat and vent only applications are not cutting the mustard in today's market. So you have low unemployment, you have worker retention issues, and so many companies are realizing that improving the environment of their facilities is a key initiative to further their core business and keep their workforce around. So we're seeing people that have never considered this idea before realizing that it's something that they have to do to compete in today's marketplace. So when I talk about big open spaces, our focus is really that 15 to 20,000 square foot and larger category, generally with 15 to 20 foot ceilings or higher. That's intentionally a nebulous range. There's certainly exceptions to that rule, but that gives us a good starting point. What I wanted to do is just to highlight a couple of case studies that I think will help illustrate what the heck I'm talking about here, and maybe nicely juxtapose this concept from what we see in a more traditional sense. So to start with a little mom and pop shop down in Houston, this is Daikin's manufacturing facility right outside of Houston in Waller, Texas. So this is one of the largest footprint buildings in the world. I think it's in the top 5. It's 4.2 million square feet. And although Daikin makes some mediocre equipment, they opted for the excellence of Johnson Air Rotation to serve their own buildings. So what I'd point out here is that what you're looking at on the bottom right is a construction photo. That big long section is the distribution side of that facility, which is all heated and cooled. So what I often point out here is that there is nothing up there. So what we're talking about, a key initiative, is bringing things down from the roof and down to grade. So you have nothing interrupting your roof, no roof penetrations, leak potential, and all maintenance is brought down to a much more accessible level. So you see on the left is one of these vertical ductless air handlers, which are air rotation units, and there are about 17 in that distribution side, and then the balance are on the manufacturing side. So this is a quintessential example of a big distribution center, like wheelhouse, steak and potato type category of where this stuff is applied. We get into manufacturing. Sometimes there's nuance involved here in terms of design that might involve some heat gain. Higher industrial clients often have plastic injection molding, sensible heat from ovens or other production type processes. And this was no exception. There on the right, you have heat generated from a lot of CNC milling and machining operations, but also a lot of oil mist and particulate that was being generated through the machining operation to make custom industrial kind of lubrication systems for SKF. So this is right next to the St. Louis airport. I'm flying it out of this thing over this building all the time. And they started originally with conventional unitary, and with switching to air rotation, we're able to pick up significant efficiencies in pursuit of some lead initiatives, along with some considerable financial savings by eliminating all of the parapet and screening walls that were on the roof. So SKF actually just copy and pasted the warehouse space you see there to the left next to their building and added another couple units. So those are both new construction. We do a significant amount of retrofit work. So one of the more common questions that comes across my desk is, hey, I've got something in this, in perfect category size of, 250, 500,000 square feet. The guys next door have air conditioning. We're losing our whole workforce over there. We got to add cooling. How do we do that? And so by default, inevitably, the first approach is we're going to mimic what we see at Home Depot, right? We're going to sprinkle a bunch of light commercial rooftops all over the roof. And that can certainly work. We've seen it all over the place, but this approach is often much less invasive to the building. You don't have to modify structure. And here was no exception. Integrity's up in the tropical city of Fargo, North Dakota, which seems to be kind of a window manufacturing mecca. But Integrity is a subsidiary of Marvin. So they had wood and vinyl and fiberglass window assemblies they're cutting in there. And before, just unit heaters and some fans. So it was a significant improvement to add cooling and hugely improved the overall indoor air quality throughout that site. We mentioned industrial process and heat in the great state there of Colorado. This is actually over in Aurora. We start touching on significant wattage per square foot in grow applications. And in this example, I thought we had, started to chart some new waters here with the grow room space, but I was wrong. We had been doing vertical farming operations up in northern Indiana and many other states across the country for some time. So these units, we had to not only handle the sensible, as with any grow operation, the latent was a key design criteria. So we have humidity control built into these units. And then we had to guarantee temperature and humidity uniformity throughout. So often I hear that air rotation is kind of like a tempering exercise, or it's a great idea, but we need consistency. In reality, the way that these operate in the holistic nature of their conditioning approach is basically taking the entire volume and churning it back to the unit continually. And in doing that, we can ensure exceptional uniformity throughout. And for a grow application, for food and beverage, for FDA compliant pharmaceutical sites, precision manufacturing, all of these are very good applications where we can hold very tight conditions throughout. If you think about this in terms of other system types, what was originally slated for this approach was a bunch of unitary on grade ducted up and in, and about 17 miles of ductwork and fans and all sorts of ancillary items to get the mix going on for that consistency. All of that was consolidated into 8 air rotation units to serve this space.
Nice.
These industrial sectors are certainly what we deal with every day, but what we're seeing a lot of growth in is in the recreational realm. If you were asking yourself why the Broncos won the Super Bowl a number of years ago, the answer was clear to me. It was because they had Johnson Air Rotation serving their practice facility. This was preceded by the New York Giants and is kind of the gold standard and benchmark for these big open NCAA and NFL applications. Here's another handful of them. And so what you'll notice in all of these is that you have 0 trunk lines running down the building. You have 0 fans to interrupt the space. and you're able to really nicely de-stratify, not interrupt the field of play. And this has kind of become just the way that these big open boxes are handled for football. Now, not exclusive to that, if you think about it more in terms of a community level, school gyms even, and done a lot of community rec centers. And this greatly simplifies not only the design, but the execution as well. I mentioned 15 to 20,000 square feet and larger is the general category for these. We have a product geared towards the smaller side of things, and this is Johnson Light. Johnson Light is a pre-engineered variant of those big units and is available in 10, 20, and 35 tons. So this is designed to pair, its core intent was to be paired with Daikin VRV. But these can operate with DX, hot water, chilled water, electric heat pump operation, obviously. The only thing we don't do integral to these is gas heat. But for smaller spaces, this can be a terrific and simple advantage for design and space, and get rid of all ductwork, all structure, etc. Regardless of the application, we start with the question of where can we put equipment, all right? When we start with a big open box, we start with coverage. So it's not uncommon for a single unit to handle 100,000 square feet or more. And there's a lot of flexibility where you can put it, right? Inevitably, the most common, I guess, knee-jerk reaction I get to this approach is, hey, Sam, this is a great concept, but I just don't have any floor space to give you. I mean, that is the most common initial rebuttal, so to speak. But as you can see here, there's significant amount of flexibility in where you can put these. And in 99 out of 100 times, when we draw things to scale and show one unit is going to serve 100,000 square feet or more, I have found that hesitation usually stems from the idea that we're going to plunk one of these things every 150 feet in the building, and it's going to become a maze of air rotation units, where that's certainly not the case. Once we have coverage established, we then tailor these modules, much like you would a horizontal air handler. We just do so in the vertical for whatever you might need. And you can see by these numbers, you can put a massive amount of capacity into a single unit. So a key discussion point here, and one that I hope, if there's any key takeaway, is inevitably we get into the conversation of system cost. And if you have to get 500 tons of cooling into a building, and we're being compared to conventional unitary equipment, we lose that battle 9 times out of 10 on a cost per ton basis for sheer equipment. So it's very important to look at that blue criteria, which is the required subtrade or ancillary subtrade costs associated with turning things on and making it work in a building. When you think about the streamlining of mechanical systems, there can be architectural reduction, elimination of structure, consolidation of electrical. All of this plays into the overall value proposition of this air rotation concept and idea. So it's important to evaluate these systems holistically to see that value. But what we really, I guess, contend with is 9 times out of 10, this is really a concept that is never even considered. And so I share this message and idea with you that if you have big open spaces of pretty much any category, this approach should certainly be evaluated to see if it has any merit or furthers, your core business and simplifying design and or streamlining installation from a mechanical perspective. We have a tremendous amount of precedent and case study. So it is exceptionally rare that we find a new application where we don't have some great background of where we've done a dozen of buildings just like that. And so we have a whole group of engineers to support your efforts on the design side or in the engineering community or in the design build capacity to help you differentiate your offerings from your competition or streamline your design efforts. So please use that as a resource. And I know Long is a a new partner and rep to us there locally in Colorado and Utah markets. So I'm sure they will be a very good resource for you as well. We're excited to have them on board, but welcome you to explore this idea and certainly happy to help in any way we can.
All right. Well, thank you, Sam.
Check out these prizes, by the way.
Yeah.
Not too
All
shabby.
right. Sam, thank you for doing that. Yeah, we're excited to be part of the team supporting and selling Johnson Air Rotation Unit. So thank you for the presentation, Sam. If you have any questions, if you're tuning in today, please contact your DeLong sales engineer, whether it's questions or opportunities that are on the horizon. We greatly appreciate the opportunity to help you out. Thank you once again for joining us today. Next week, Mike Jacobs is going to be presenting on mastering harmonic mitigation with Yaskawa HV600 VFDs. Until next week, thank you, take care, and be excellent to one another.